Okay, in this video, I would like to talk about how to classify functions as either odd, even, or neither. I want to talk about what's the technique we can use to tell by hand whether it's odd, even, or neither. And also, we're going to take a look at the graphs of functions to tell whether they're odd, even, or neither as well. So let's take a look. Let's classify our functions as even, odd, or neither. So let's talk about what even, odd, or neither means. First of all, if I have f of x is equal to f of negative x, meaning I take all the x's in the function and I replace them with a negative x. If I simplify that and I get the same thing as the original function, then the function is even. I say I have an even function. F of x is equal to f of negative x, means I have an even function. But if I have that f of negative x is equal to putting a negative in front of the whole original function, and I get that these are equal, then I say I have an odd function. So if I take all the x's and replace them with negative x and compare that to putting a negative in front of the entire original function, then I say that it's odd. So let's see some examples. They'll have to give you a function. So let's say they give you 2x squared plus 5. Now let's check and see if it's even first. So if I take the original function and let's say I want to replace all the x's with a negative x. Let's see how this looks. 2 negative x, and then I have this raised to the second power. So I'm going to put the parenthesis in there. So I have negative x raised to the second power plus 5. Now, if I do negative x to the second power, that's going to make the negative go away, and I get 2x squared plus 5. If I look at this and compare it to the original, it's the same thing. So since they're equal, I say, oh, this is an even function because of the definition I see up top. F of x is equal to f of negative x. Let's see another example. So let's say they gave me the function f of x is equal to negative x to the third power plus x. Now let's check and see if it's even. So I have f of negative x. That means I'm taking all the x's and replacing them with negative x. Negative x to the third plus negative x. Now, if I do negative x to the third power, that's still going to give me a negative. It's not going to make the negative go away. So I'm going to put the negative in front with the 5, and I get negative 5x to the third minus x. And when I look at the two, when I look at this and the original one, they're not the same, so I say that it's not even. But let's keep this f of negative x in mind. Let's rewrite it. F of negative x is equal to, after we simplified, we got negative 5x to the third minus x. Now let's compare this to negative f of x. So putting a negative sign in front of the whole original function. Put a negative and then I write the original function. Now let me simplify this. That means I have to distribute that negative sign and get negative 5x to the third minus x. Okay, these two look the same. And since they are the same, I say that I have an odd function. And the reason I have an odd function is because f of negative x is equal to negative f of x. F of negative x is equal to negative f of x. And that is why we have an odd function. Okay, let's take a look at this in our graphing calculator. So let's go to our y equals, and we're going to enter the function that we were working with before. Let's enter 2x squared plus 5. And what I'm going to do is go to zoom, and I'm going to make my window go from -10 to 10. So that's Z standard. And as you see, the parabola is right here. Now this function is even. All even functions reflect on the y-axis. That means if I folded the graph over the y-axis, it would be the same on both sides. Let's look at another function. Like, I'm going to turn this one off by pressing enter on the equal sign, and I'll go down to y2. And I'm going to put x squared. Let's just do x squared and take a look at this one. Same thing. This graph, if I was to sandwich it over the y-axis, it would look the same on both sides. So therefore, that is an even function as well. So let's do x to the 6th power. And same thing. This is a function that's even, and we know that it's even because it reflects on the y-axis. Now let's clear all of this out, and let's look at an odd function. The function we were working with before was 5x to the 3rd power plus x. Now let's go to our graph to see what it looks like. And as you see, it goes up and comes back down here. Now, for a graph to be odd, it has to be able to reflect over the y-axis and then reflect down on the x-axis. So you fold it over to go across the y, and then you fold it down to go across the x, and it should land on top of itself. Let's look at a bigger window from -10 to 10. Same thing. If I fold this graph over the y and then bring it down over the x, it's going to land on top of itself. Therefore, this graph is odd. That means it reflects on the origin. If a function is odd, that means that it reflects on the origin. Let's look at another example of an odd function. And again, this graph, if I took it and folded it over the y-axis and then fold it down, it's going to land on top of itself. Thank you for watching. I'll see you next time for the next video. Bye.